Hello, students. Welcome back to another day in organic chemistry. And today is a really important day, so I'm going to ask you to really try and pay attention. Hopefully you have reviewed your notes from yesterday, and we're going to be utilizing a lot of that as we plow ahead today. So let's begin in our notes, and we're picking up where we left off last time with naming hydrocarbons. Naming hydrocarbons. Now, as you know, organic chemistry is all about the chemistry of carbon, and one of the most prevalent types of carbon compounds are those that are formed with hydrogen. So when you look at the name here, hydrocarbon, hydrogen refers to the hydrogen. Hydro refers to hydrogen, and carbon obviously refers to carbon. So what we're going to be talking about here today specifically relates to hydrocarbons, which make up a lot of organic chemistry. But the principles we'll pick up today will also apply to other types of organic compounds, not just those with hydrogen and carbon. So let's move ahead. First, a word about words. You know that words are very important, especially in science. We've spent many months talking about the importance of words in science. And we learned early on in the year about prefixes and suffixes and about dissecting words. Well, as we continue with this topic of organic chemistry, we're going to be really utilizing our dissection skills to dissect these words into prefixes and suffixes, because the meanings are just so incredibly important. So let's begin with prefixes. The prefixes of organic molecules, and in particular, again, we're talking about hydrocarbons. When we are dealing with the names of hydrocarbons, the prefixes tell us something very important. You always want to look at the prefix because the prefix will tell you in its name the number of carbon atoms that exist in a particular molecule. Now, how will we know what that number is? Well, I'm going to give you the list of the first 10 prefixes, and these are the only prefixes you will need to know, and you can even refer to them in your book. So let's begin. Meth. METH is the first prefix in naming hydrocarbons. Whenever you see an organic compound beginning with the word meth, and I am sure that some of you are already thinking of other organic compounds beginning with the word meth, well, now you're going to know something when you hear those words. Meth is the prefix that means one. More specifically, one carbon atom. So if I were to show you a model here of an organic molecule, and the black sphere represents carbon, the carbon right in the center here, the name of this would begin with the prefix meth. And if I were to use another model of a smaller size, same principle here, this compound, whatever it is, and before the end of the period today, you're going to know what to name this, but it's going to begin with the prefix meth because meth means one carbon. So whenever you see meth, you know it's talking about one carbon. F, E-T-H, E-T-H. F refers to the number 2. 2 carbons. So here's one model showing that there are 1, 2 carbons. So the name of this will begin with the prefix F. Here's another model. Looking at it, you can see that it's got 2 carbon atoms. This would begin with the prefix F. Let's continue down the list. Prop means 3. In the laboratory, when we light up the Bunsen burners, we use something called propane. Propane. Maybe some of you have gas grills at home that use propane. Well, prop means 3. So prop, if we were to build a model of an organic molecule having 3 carbon atoms, here's 3 carbon atoms. This is what it might look like. In fact, this is propane. We'll find out about the suffix in a moment. And again, here's another model with 3 carbon atoms. So its name begins with the prefix prop or prop. Okay, prop. All right, let's continue with the next prefix here as we go down in our notes. This is not a but. This is pronounced butte. B-U-T is butte, and what a beauty it is. Butte, and here's an example of a model with 4 carbon atoms. Butte, you may have heard before if you know anyone who might smoke. Cigarette lighters are filled with butane. Butane. Butte refers to 4 carbons. 5 might sound familiar to you. Here is a model with 5 carbon atoms. 1, 2, 3, 4, 5. Yep, I grabbed the right one. 5 refers to pent, or I should say pent refers to 5. Maybe you've heard of the Pentagon, the world's largest 5-sided building, the Pentagon, down in Arlington, Virginia, outside of Washington, D.C. So meth, eth, prop, bute, pent, 1, 2, 3, 4, 5. These are going to be some of the more common ones that we will be using for the remainder of the week, but I'm going to give you the other ones up to 10 as well. Hex, like a hexagon. Hex means 6. Hept, like a heptathlon in the Olympics, means 7. Oct, as in an octagon, means 8. Non is 9. And finally, dec is 10. So here we have the complete list of prefixes for us, at least this year: meth, eth, prop, bute, pent, hex, hept, oct, non, and dec, from 1 through 10. All right, so what do we do with these prefixes? Well, we put them together with suffixes. And the suffixes also have an important meaning in organic chemistry, because it is the suffix that will tell you what type or kind of bond exists between the carbon atoms. Let me explain. The first suffix for us to focus on refers to ane, or pronounced ane, and ane represents all single bonds. So if I were to show you this model here, which by the way is illustrated on the screen as well, but this model shows carbon atoms, 2 carbon atoms that are connected with a single bond. There's one rod, one single bond. And a single bond in organic chemistry is identified with the suffix ane. So here we have 2 carbons. 2 refers to F, the prefix F, and all single bonds. Ane is how we summarize that. This is actually a model of ethane. Ethane tells you, F tells you 2 carbons, ane tells you all single bonds. And any organic molecule that ends in the suffix ane belongs to a group of hydrocarbons, in this case, called the alkanes. So ane, single bond. Let's move on to the next one. ene. refers to double bonds. Here is a model of a hydrocarbon. Here's the carbons, here's the hydrogens, and you can see that there is a double bond between the two carbons that is summarized with the suffix ene or ene. Now again, this model has two carbons, so what prefix might you use? What prefix to represent two carbons? Again, it would be F, but what would the suffix of this compound be? Not ane, but ene. So the name of this compound, of this hydrocarbon, would be ethene. This is ethene. This is ethane. This is ethene. Do you see the difference between the two? That brings us to the third type of bond, which is a triple bond. And we abbreviate a triple bond by using the letters Y-N-E or ine. Ine. The Y is pronounced like a long I. Ine. So here's a model of a triple carbon bond, 1, 2, 3, and this would be abbreviated with the suffix ine. Now again, there's only two carbons, so what prefix would we use? F. The name of this substance would be ethyne. This is ethyne and belongs to the alkyne group. Unlike ethene, which belongs to the alkenes, and ethane, which belongs to the alkanes. So we've got the alkanes, the alkenes, and the alkynes, the anes, enes, and ines, and I'm going to give you a quick way to remember which one is which. Think of your ABCs. I've underlined these letters, and I'd like you to underline the letters as well in your notes, A, E, and Y. Notice they are in alphabetical order. A, E, Y in alphabetical order, single, double, and triple bonds. Review these prefixes and suffixes many times between today and tomorrow because you're going to need to rely on these prefixes and suffixes to understand anything going forward in organic chemistry. So let's go over here and let me introduce you to one last word here, which is one of the reasons why we have organic chemistry, and more specifically, why we have structural formulas in organic chemistry. And it's this word, this vocab word, isomer. An isomer is a compound with the same molecular formula, but different structural formulas. What in the world does that mean? Well, here's the deal. Yesterday, we mentioned that how familiar you are with molecular formulas like CH4, H2O, NaCl, etc. All of those are molecular formulas. But in organic chemistry, you can have two or more substances that are completely different and have the same molecular formula, but are built in different ways, which gives them different characteristics altogether. Let me give you a for instance. Here I have two different substances. Butane, which I mentioned before, exists in cigarette lighters, and another substance called isobutane. And we use the prefix iso because it is an isomer. Well, what exactly does this mean? Well, let's check it out. Look at the structural formulas. You can see right off the bat that these are two completely different structural formulas. Let's think about what the molecular formulas might be. What would the molecular formulas be of butane? Count the carbons, 1, 2, 3, 4, and count the hydrogens, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the structural formula of butane would be C4H10. But now let's look at isobutane here. How many carbons are there? 1, 2, 3, 4, same number. That's where the but comes from, but for 4. How about hydrogens? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Same number of hydrogens. So here we have two different substances, butane and isobutane. But even though they have the same molecular formulas, they're not the same thing because they have different structural formulas. Let me build for you butane. I'm going to use some of my models here, and I am going to model for you butane. Now, as I make a model of butane, how many carbon atoms are there in butane? But. It's a real but. But means how many carbons? 4. Ane, butane, the suffix, what does that refer to? The type of bond between carbons. And ane refers to all single bonds. So here I have a model of butane. Here's a model of butane. 4 carbons and all single bonds. But if I build this a little bit differently, in other words, what could I do? I could remove the bond here and remove this one from here and structure this differently so that we've got our 3 carbons up top and a carbon coming down from the center here. Check out this model. This is what the structural formula here is showing. This is isobutane. The same number of carbons, the same number of hydrogens, but configured differently. There are a lot of those in organic chemistry. So when you see the prefix of iso, you know you're dealing with an isomer, which means it has the same molecular formula as something else, but a different structural formula. All right, keep that in mind as we move ahead. So let us move ahead and let's go through some examples here so that we can catch on perhaps a little bit easier. This is something good to write down. This is kind of a flow chart for how we will begin to build and name our organic molecules. I'm going to give you a name. Not you personally, but I'm going to give you an example of a name of an organic molecule, a particular hydrocarbon. You're going to look at that name, and you're going to look at the prefix. And when you look at the prefix, that's going to tell you how many carbon atoms are going to be in one molecule of whatever name hydrocarbon I give you. So the beginning part of your flow chart here tells you the number of carbons by looking at the prefix. The second part of the name is the suffix. And the suffix will tell you the type of bond that exists. Is it a single bond, a double bond, or a triple bond that exists between carbon atoms? So again, write this down. Flow chart for taking the name and figuring out the prefix, number of carbons, suffix, the type of bond. But we're going to take this a step further. Because from that name, I would like you to be able to create a model of the hydrocarbon with nothing but the name. So the name tells you the prefix and the suffix, tells you the number of carbons that you're going to get together for your model and the type of bonds that you're going to construct with your model. And from the model, you will then be able to hold that model in a particular way to provide you the means by which to draw a structural model on paper. So you're going to take the three-dimensional model and give it a two-dimensional representation on paper. And from that two-dimensional representation of the structural model on paper, you will then be able to write the molecular formula. Now you'll notice as you have written this down in your notes that I have arrows going in both directions because you will in fact be able to go both ways here. If I give you a molecular formula, you should be able to draw a structural formula, then create a model, and also give it a name as well. So I want you to be able to go up and down with this flow chart here from name to model to structural and molecular formula and back again. So let's see how we make out, shall we? We'll do some together. Starting with a simple one, methane. Methane. Everybody all together, and feel free to look at your notes. Tell me what the prefix meth means. One carbon. Very good. And the suffix ane, what does that refer to as? What does that refer to? Ane. Everybody? Single bond. Very good. So meth is one carbon, ane, all single bonds. Now, this is kind of an easy one, and I will show you on paper and in real life the model of methane. Here's a model, and I'm holding this model up for you to see as well so that you can see it, and I can turn it around and orient it in different ways. This is going to be really important in a moment. In fact, I'm going to orient my model toward the camera just like this, and you'll see why in a moment. But you can be drawing that model down in your notes. And if you hold the model like this while you're looking at it, you will be able to draw the structural formula. The structural formula, you have the carbon in the center, and you have single bonds coming out from that carbon. And on paper, we draw them vertically and horizontally in this case, so that the bonds are perpendicular to one another. And at the ends of each of those bonds, since we're talking about methane, only one carbon, the rest of those bonds are connected to hydrogen atoms. So that is the structural formula for methane. Now we have one more step to go here, and that is to take the structural formula and write a molecular formula. Remember, a molecular formula is going to show us what kind of elements and how many of those elements there are, and we represent the number of atoms of each element with a subscript. So how many carbons are there here, everybody? One. How many hydrogens are there here, everybody? 4. So our molecular formula is CH4. Remember, when there's one atom of an element, we don't write the number 1. The subscript is implied. The subscript is implied. Okay, so now let's do an activity here together. Let's do an activity here together, and I'm just skipping in my notes here to the next example. If you need to watch that again, feel free to rewind it and watch it again. But I'll summarize it once again with our activity. I'm going to give you the name of a hydrocarbon like methane. The meth refers to one carbon, ane refers to single bonds. So drawing a model or creating a model in 3 dimensions gives you this. Manipulating the model so that you can see it head on will help you write the structural formula. And from the structural formula, you can write the molecular formula. All right, so here's our first real example activity, and there's room on the bottom of your page to do this. Let's do this one together. And so we look at the prefix of this first, and the prefix is F. Look in your notes, and when you know the answer, call out for me. What does the prefix F mean? F is 2. 2 carbons. So we're going to get 2 carbons together in our model. So here is a model of ethane. And I'm going to hold it for you because I'm manipulating it here for you. So I'm going to hold this model of ethane so that you can draw in your book the structural formula of ethane and then draw the molecular formula. So you can pause the video here for a moment to give you enough time to go from the model. Ooh, look at that. I'm putting the carbons right in front of my eyeballs. That's a good idea. Okay, carbon in front of my eyeballs here. All right, so from this model, draw the structural formula of ethane and then the molecular formula. Pause now. All right, hopefully you got that. Our next one is propane. Propane. So while I'm building the model, because I know what it should look like, you tell me. Look at the prefix prop. How many carbon atoms should we have in propane? Everybody. 3. And what kind of bonds exist between all of the carbon atoms with a name like propane? Single bonds. Very good. So here is a model of propane. There's 3 carbon atoms, and at the end they have all single bonds, and at the end of all the bonds are hydrogen atoms. So I'm going to hold this for the camera right like this. I'm going to try and get out of the way a little bit so you can see a little bit clearer. But take this model, and notice you can orient it differently, but I'm going to orient it so that you can have an easier time of drawing the structural formula first and then the molecular formula. So feel free to pause the video and draw the structural and then molecular formulas. Very good. Hopefully you were able to get propane without any difficulty. And hopefully you're able to catch on with how we go from a name to a model to the structural formula to the molecular formula. Let's try another one here. All right, let's make it a little bit more challenging. Ethene. Ooh, notice I changed the suffix. But again, let's look at the prefix. The prefix F means how many carbons, everybody? Very good, 2. And now let's look at the suffix. What does that suffix refer to? What type of bonds? Double bonds. Excellent. So ethene, sorry, I just lost some methane on the floor there. But now I've got some ethene. Here is a 3-dimensional model of ethene. ene. Notice the number of carbons and the type of bonds that exist between the two. So I'm going to hold this ethene and try not to get my fingers too much in the way here. And I'm going to hold it for you so that you can draw your structural formula and then your molecular formula. Remember, the black is carbon and the red is hydrogen. So draw ethene, structural and molecular formula now. All right. Hopefully you were able to get that with little difficulty. And now for the next example, which is ethine. Ethine. Oh my, we're getting a little bit more challenging here now. Ethine. All right, eth. What does the prefix mean, everybody? Two. Excellent. And it ends with another suffix, yne or ine. What does that refer to? Triple bonds. So I have built a model of ethine for you, and here it is. I'll hold it for the camera for you to see, and I would like you now to draw the structural and molecular formulas for ethine. Ethine. Excellent. So you've had some good practice here today, taking names, using those names to draw, or rather to create models, then draw structural formulas, and from that, write molecular formulas. And I want you to remember the flow chart that we went over. When given a name, create a model, draw the structural, then the molecular formulas, and be able to go back and forth. And the only way to do that effectively is to know the prefixes and the suffixes and what kind of information that tells you. I'm hoping that this is going to be a good preparation for you for our lab activity tomorrow. So until then, I would encourage you to watch this again if I've totally lost you. But for now, I will say bye-bye.